graphing lines last year? Beautiful. It's a very easy process. I've made the process even easier with these step-by-step instructions. The first thing we're going to do is identify slope and y-intercept. We got some help with our warm-up, remembering what it means to do step one, which is great. And as we know, slope is represented by the letter M, and the y-intercept is represented by the letter B. Not Y, B. Okay? Y is still Y. So after I identify what M and B are, if my M is not a fraction, I'm going to turn M into a fraction. If I have a number like 4 and I want to turn that 4 into a fraction, what should I do with it? Precious, what should I do? Put a 1 under it. Put 1 under it. Right, if I see my slope from the equation I'm given is -3, I'll put a 1 underneath that. We'll see why in just a second. So, I got to organize my information. I figure out what's my M, turn it into a fraction, figure out what's my B. Then I'm going to start my process. I'm going to begin by plotting my B on the y-axis. For some of you, this may be oversimplification. Some of you, this may be just what you need. So if this feels super easy, that's great. If it feels doable, that's also great, even better. So I'm going to begin by plotting my B on the y-axis. I'm going to use that kind of as my beginning point. From there, I'm going to rise. I'm going to rise however many spaces are in my M's numerator. Where can I find a numerator? Yeah, Alex? Top of a fraction. So whatever number's on the top of my slope fraction, I'm going to rise. Now what's really important is, bless you, if my slope is positive, I'm rising up. However, if my slope is negative, what direction am I going to rise? Down. I'm going to rise down. That's why it's really important that we keep our negative signs in the numerator, because that numerator determines whether I'm going to go up or if I'm going to go down. If I keep my negative sign in the denominator, which we should never ever do, that's really gross and offensive, keeping your minus sign in the bottom, then that kind of mixes this whole process up. We don't want that, okay? So I rise up, I rise down. What do I do after I rise? I gotta run. I'm gonna run the number of spaces in my M's denominator. Did Miss Henson, Mr. Smith, and Mr. Bahar all teach you rise over run last year? Yeah. That sounds familiar? Okay, good. That's right. Rise is going up or down. Run is always going to be to the right. Okay, I'm always going to be running to the right. Okay, any ideas on why I'm always going to be running to the right? Why am I never running to the left? Think about it for a second. Alex, no? Precious, got an idea? I'd be in the second quadrant?
Yeah,
or
that one.
This one right here?
Yeah, or the bottom one.
Okay. Well, that's a good thought. I definitely would end up, if I go left, I'm going, to this side. Let's see, once we do it, maybe we'll be a little bit clear on why we always run to the right. But we're always going to run to the right. Wherever I land after doing that rising and that running, that's where I make my second point. And I'm going to continue this pattern. Okay. We're going to continue this pattern as much as we can until we run out of space on our graph. Okay. Now we only need to do this when we're on paper. Right? And the reason why is, yes, we technically only need 2 points in order to make a line. But because some of the dots that we make are really, really fat, some of the dots we make are really, really thin, people's lines are slightly off when we are doing it on paper. Okay? The more points we have, the more accurate and precise of a line we can make. If we're on Alex or something, we only need 2 points because the computer makes a perfectly straight line every time. But we're humans, we have errors. Okay? Then we're going to reverse both directions and go the other way. We'll look at that in a second because it's a little confusing. All right, let's get to it. Here's my equation. What's my slope here in this equation? Everybody, what's my slope? 3/4. 3/4. Do I need to make that into a fraction? No, because it's already a fraction. What's my b value here? 2. The letter B stands for begin. Also y-intercept, but more easily rememberable, it stands for begin. Okay, this is gonna go quick, so I wanna make sure everyone's watching. All right? Let's figure out my directions, okay? Because when I am going somewhere, a restaurant or something, and I don't know where it's at, I got to put the address in my Apple Maps and figure out what the directions are, right? My phone only knows what directions to give me because it can tell where I am right now. You guys get me on that?
Yeah.
So we're going to begin at 2 on the x-axis or the y-axis?
Y-axis.
On the y-axis. Go ahead and make a dot at +2 on the y-axis. That's my beginning point. You remember this now? Good. Now my slope has 2 numbers. It tells me 2 directions. It tells me my rise and it tells me my run. If my numerator is positive, what direction should I be rising? Up or down?
That way, right.
To the right?
Yeah.
Up or down? I should go to the right? I'm rising up and I'm running. Which direction, Oscar?
Right.
To the right. Positive, positive. If I uplift you, that's a positive thing. Up is positive, right? For a lot of people, if you die and go upward, that's a positive thing, right? If that's what you believe in. If I'm going to the right, right is also positive, right? You do something right, you get a question right, those are all positive things. So if my denominator is positive, I'm going to the right, right? So why am I always running to the right?
Because it's right.
Because it's right. Is my denominator ever going to be negative?
No.
No, I always throw that negative sign up top. So if my denominator is always going to be positive, then I'm always running to the right. Is this right to you guys? Yes?
Yes.
Okay. It's left to me, but it's right to you. All right? So my phone knows where I'm at, and now it can give me the directions. I'm going to start at my beginning point. I'm going to rise 3 spaces up. 1, 2, 3. And I'm going to run 4 spaces to the right. 1, 2, 3, 4. Where I land is where I make that second point. I'm not making a point in between. I'm waiting until I finish both movements till I make my second point. This is called a slope triangle. Okay? Everybody with me on that? Yeah? Okay. Now, can I go 3 more spaces up and 4 more spaces to the right? No, I'm going to get off the graph. I don't have any more space to do that. However, I have a lot of space over here. So, I got to reverse directions. Instead of going 3 spaces up, now I'm going to go 3 spaces down. And instead of going 4 spaces to the right, I'm going to go 4 spaces to the left. Back to my beginning point I go. Now I'm going to go down 3 left 4, and make my third dot. Now, do all 3 of those dots line up perfectly?
Yes.
Do they all make a line if I were to connect them?
Yes.
Yes, they do. Everybody has their ID card on them, right? Perfect. Go ahead and take your ID card out. Everybody should have an ID card issued to them for free by the school. Aisha's getting hers out right now. I see it. That's great. Okay. There will be no free handing of straight lines in this class, ever. There will be no free handing your straight lines, ever. You're going to line those points up. You're going to go all the way through the graph. Check it out. All the way through the graph. I'm not playing connect the dots. I'm going all the way through because what am I going to stick on the ends of this line? Arrows. Your arrows should not be on the grid. I'll say that again. The 2 arrows that you draw should not be located on the grid. They should be off the grid. You guys see what I mean when I say off the grid?
Yes.
Okay. Okay. Don't just do this. Don't connect the dots and make a segment. We're making a line going all the way through with arrows on the end. There's my line. Y is equal to 3 over 4x plus 2. I have a y-intercept of 2 and a slope of 3 over 4. Quick show of thumbs. How much of this are we remembering? Thumbs up if this is literal deja vu and you remember this lesson exactly. Thumbs sideways if it kind of sounds familiar here and there. Thumbs down if you definitely did not learn this last year. I want to see everybody's thumbs just so I know where you're at. Okay. Cool. Very nice. Let's get the second page. Because they're not always going to be that straightforward. Sometimes we're going to have things that we need to look out for. Just like in life. There you go. There you are. There you go. Yep. 0. You asked.
Actually,
Yeah, no one got 100%.
I thought I did.
You thought you did?
Your test.
The highest score was a 49 out of 50. Just one little point. Ah, that's where mine went.
I knew I did. Oh, I'm talking about my test. I think I got the 49.
All right, let's take a look at some special cases here. Because that first one felt a little too easy, didn't it? I think so as well. Was low-key kind of hard? All right. Let's take a look at example B. Example B, what's my slope in example B, everybody? What's my m equal to? 2. Now, when I put the directions in my phone, right, I don't want them to just tell me to go 3 miles. I want them to tell me what direction to turn after I hit that 3 mile mark. So what can I put underneath this 2 to give me another direction? A 1. What direction will I be rising here, up or down?
Down.
Right.
Yeah. Up.
Check the numerator. Is it positive or negative? Positive. It's going up. What direction am I running always?
Right.
To the right.
That's right.
Where do I begin here? At -3. On which axis again?
Y.
The Y. Everybody cool with how we set this up? Okay. I'm going to begin at -3. Boom. There's my beginning point. All right. I'm going to rise 2 spaces up. 1, 2. And I'm going to run 1 space over before making my dot. Okay, again, I plotted my beginning point. I rose 2 spaces up. I ran 1 space over. Then I drew my second dot. Now again, technically I only need 2 dots in order to make a line. But because of our human error when doing this on paper, we want to continue this as far as we can to get a nice precise line. So from this second point, I'm going to rise 2, run 1, and make a third dot. Is that third dot in line with my first 2? Yes. So I'll keep going. Rise 2, run 1. All the way up as far as I can go. Does that look all right?
Yeah.
Now I'm going to reverse it. I'm going to go back to the beginning. Okay. I'm going to go down 2, and I'm going to go 1 space to the left and make my last point down there. Again, if it lines up with all my other points, I know I did it right. If it looks kind of out of whack or out of the line, then I know I definitely messed up my directions somehow. I'm going to connect all those together and make my line. Just realized that slope was supposed to be negative, but that's okay. So once again, notice how my line goes all the way through my graph to the point where my arrows, the physical arrows, are not on the grid itself. They are outside of the grid. All right? Everyone cool on that one?
Yeah.
Okay, so don't forget to put the 1 under. Tells me a lot. Example C. What's my M here in example C?
3, 0, 0.
3, 0, 0, 3, 3, 0.
0.
My M here is 0. I don't see an X, which means I must be adding 0x in my equation. So then what's my B? 3. Now this is where a lot of people get stuck. Because they look at their slope and go, 0? Well, what am I even supposed to do with that? I'll show you exactly what to do with it. That's right. What do we normally do with a slope that's not a fraction? Put it over 1. Now, 0 is positive or negative? Neither. So we'll just rise up. You can rise down. You'll see why it doesn't matter. But I'm always going to run to the right. Okay? Where's my beginning point going to be again? Positive 3. I'm going to rise up. How many spaces?
None.
0. And I'm going to run over 1. So that dot, that second dot, should be right next to that first dot. And I'm going to continue this pattern as far as I can. I'm going to rise 0, run 1, make a dot, rise 0, run 1, make a dot. You guys can kind of see what's happening here, right?
Yes.
And I'm going to go now to the left. I'm going to reverse it. What type of line did we just construct? Starts with an H. Horizontal line. This is why, if you'll remember, in our last unit I said, if I have a line like y equals 3, this is when we were talking about line of symmetry. Y equals 3, I make a dot at 3 on the y, and then make my flat line. If there's no x visible in the equation, my line should never touch the x-axis. This is my x-axis. Is the line we constructed ever going to cross the x-axis? No. All right? Does example C sound okay? Yeah? Okay. Example D is a little bit different. What does example D say? X equals -4. So there is no y here at all. That makes things a little bit different. Okay? Anyone know what my slope is going to be here? -4/1. That's a good guess. If the x was glued to my -4, you'd be right, Isaac. 0. That's another great guess. Capiche? 0/1. Another great guess. Ben? 1/1. Another great guess. Bavia? Precious? 1/0. You're not wrong. What does 1/0 equal to? 1, 1, 0, 0. Let's see. 1 divided by 0?
1 divided by 0.
1 divided by 0 is undefined. Does that sound familiar? Anyone ever heard that word before? My slope here is undefined. I am unable to define it. All done? Yeah, you just put it on my desk. The notes are on your desk. My slope is undefined. Okay? Now, what's my y-intercept? -4. My y-intercept being -4. I love that you would say that because this is a constant, right?
But is it not? Because it's x.
But it's x equals -4.
So the x is
Undefined.
So let's think about this, right?
So it.
If I were to make a dot at -4 on the x, what type of line would I be constructing? We just made a horizontal line. A vertical line. What are my y-intercepts when I have a vertical line out here at -4? I don't have any y-intercepts. It's not 0 because 0 is right here. I'm not intercepting 0. I'm intercepting nothing.
So undefined.
So there is no y-intercept.
So it's just.
So is it the same thing as undefined or is no?
There's just none. There's none. It never touches the y-axis, so there is no y-intercepts. And we saw this with our functions in the last unit. There was specific problems where we said x-intercepts, none. Y-intercepts, there's none. Okay?
Yeah.
So this example D, this one is really weird and gross. Frowny face, okay?
Why are you being so mean?
Anytime I see, I know I shouldn't be so mean, but it's all right. It's strong. It's a strong equation. It when you see x equals and then a number, that should be your kind of trigger that hey, this doesn't start with y equals like all my other equations. Something must be different about this. My slope is undefined, and my b value is none. There is none. Okay. Again, do you see the letter y in this equation? No, that means this line that I make never touches the y-axis. Do you see an x in this equation? No. Well, not I drew it, yes. But in the original equation, do you see the letter x? No. So my line is going to never touch the x-axis. Okay? So that's the difference between these two weird guys over here.